Okay. Try. I think I fixed it. You know, me and computer problems are we're just one. You know, we're just joined at the hip. It's gonna be some. It's gonna be an issue. It just that's the fucking way it is. um. So anyway, I'm trying this again after my now I'm having problems with my speaker and my headset. The port on my case is the connection is bad. You know, life is full of problems. It's really frustrating. Like changed my what do you call that? Like the background art. I don't know why it would do that, but you know that's what it did. Okay. Yeah, it sounds fine now. It sounds fine. Figuring this thing out. Uh, well, there we go. All right. So anyway, the deal is that we can't use this 10 nanosecond comparison. We have to change this value to be much larger. There was actually a fix for this. So I was working on this in test reminder. We have time now equals time ns divided by 1 billion, and that gives you um, the value in seconds um, in float format, which just means using a decimal. So I put remember that time ns uses an integer instead of the float value of time. This means that any comparison against time ns versus time ns can be compared in terms of 10. Because 10 just means 10 nanoseconds, have to divide by 1 billion. So I put time now equals time ns divided by 1 billion, copy and paste that to get seconds as float, and then I ask will it round up, and then also consider locks as issues. That was something that I forgot about, but we do have locks and they have been problematic before. So this is new after the refactoring. We didn't have locks before, so I do have to try to keep that in mind. So I put this little reminder right here, so I will think about it every time I come to my issues tab. And then consider using time sleep instead of universal delay or in tandem. So yeah, that's our other issue. We're gonna fix this first though with the nanosecond thing. So let's go ahead and I'll just copy this like I said, and let me make sure this is the same. So we have 1 2 3 1 2 3 and then 1 2 3. So So here's what we have to do. We have to add in a divider to divide this. But the only concern I have is, and this is indeed a billion, so that's hundreds, thousands, millions, billion. And if we ask ChatGPT, because I didn't actually know what a nanosecond was, and it's a billionth of a second. Yeah, 1 billionth. So nanosecond is 1 billionth of a second. 0.0. So you're gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9 digits after the decimal point on a nanosecond. 9 after. So let's go and print this out here in this test file. Well, this only gave us 6, so does that just mean that it was 0, 0, 0, 0? I mean, are the chances of that? How many digits is this? 1, 2, 3, 4, 5, 6, 7. So I don't know if this is actually correct or not. I mean, it is a billion, right? And it's a billionth. If we have a billion and we divide it by 1 billion, that should, I mean, it's 1 billionth. And that should get us to the second mark, and that's what we want. 725481426. Okay, I'm just wondering, why does this not have 9? Because if it is, like, if this is correct, it being a billionth and dividing by a billion, that would mean, wouldn't that mean we would always have the same amount of decimal points of integers after the decimal point? 1, 2, 3, 4, 5, 6, 7. Maybe not. Maybe I'm wrong here. So let me ask ChatGPT. ChatGPT's pretty smart. So we converted the current time from nanoseconds to seconds. The time function returns the current time in nanoseconds since the epoch. So dividing by 10 to the 9th, which is 1 billion, converts this value into seconds. So we'll print the current time is flipped over in seconds since Unix epoch, being more precise. Yeah, so it's ChatGPT says this is right. Now once this 1 would have to get all the way up to a 9 and then a 0, and that would add the next digit, but like that wouldn't happen for like another, probably, I don't know. Let's see how many years would it take for time ns to gain another digit due to the number growth over time. see, how many years would it take? How many years it would take to gain another digit when you understand the growth of the nanosecond timestamp? Okay. A new digit means an increase in magnitude by a factor of 10. So to gain another digit, the nanosecond value needs to increase by a factor of 10 from its current value. The current timestamp is around... Let's convert time needed in years. So for 537 years... But when we convert it to a second, that's different. Okay. What about time instead? So this is 484 years, it says, to gain another digit due to the number growth over time. So, in other words, it's going to be a long time before another digit is added. So this code is going to be reliable for the next 400 something years. So we're safe with using it as it is. So we're going to use it that, and I'm gonna put a reminder that nanoseconds are billionths of a second, and time ns returns an int of nanoseconds, not a float. If you want to compare against it in terms of integer, remember it's nanoseconds. So comparing against 10 is comparing 10 nanoseconds, not 10 seconds. Yeah, so, and let's put here, we'll just call it nanoseconds comparison conversion. And well, this is gonna be the 4th, which is my boy's birthday. Alright, now let's go over to game. Okay, so we have the so we need to change this to be if time.time ns divided by 1000. Yeah, so time.time ns divided by 1 billion rather minus begin time is greater than or equal to 10. Or you know what we could do? So actually I would rather this because it doesn't fudge the value of the time ns. Is instead of comparing it against 10, we would just, because that's 10 nanoseconds, so to get a billion, like a billion nanoseconds is 1 second, right? So to get to 10 seconds, that would be 10 billion nanoseconds, right? Because if 1 second is a billion nanoseconds, then that means 10 seconds is 10 billion nanoseconds. So this is 10 thousand, 100,000, million, billion. Yeah. So now we just remove those commas because that will change the syntax. It has to be um, it has to be written like that. Okay, so now we'd go over here and do the same thing. And now 10 seconds, and this is gonna 10 billion nanoseconds. That's insane. That's just an insane, like, that we can measure that precisely to the billionth of a second is pretty insane, dude. Like, can we actually do that? Okay. So I'm adding in that, and this should be, we'll say should be 10 seconds. And now let's, well, let's, how about this? We'll do import time, then we'll do time now, and then we're gonna say time now, time ns, and then we're gonna do time ns minus, I'll say if time ns minus time now is greater than or equal to 10 billion. We'll just verify 1, 2, 3, 1, 2, 3. So yeah, there we go. Hundreds, thousands, million, billions, and let's get rid of those commas. So that's 10 seconds. Verified 10 billion equal 10 seconds. Okay, so now we're gonna add I'm all over the place here. And it's not going to be because we have to do a delay. So we're going to get time now, then we're going to do time.sleep, and let's do sleep for 1, and we should not get a true printout. Now let's change it to 2, try it again, shouldn't get a true printout, and we don't. Now let's change it to 5 and see if we get a true printout. And we don't. Okay, now let's change it to 10. Now remember, it's going to take 10 seconds, so let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it's off a little bit there, and then see, it printed out true. So this definitely works because, as you can see, it printed out true. So this code is tested now. We verified that it does indeed work. So that's cool. I'm happy there with this. So I'll just put that I tested this code. Tested this code and verified it works. Okay, so this should have fixed that issue. And the fact of will it round up, I don't think it's not gonna round up because we're not altering it. We're not dividing it like we said we were going to, we're not actually going to do that, which is better. We're not modifying the return value of time and s. We're just actually modified the value that it's compared against, or that is subtracted from it. So we solved the enter continue text function bug, and then I'll put tested and verified, and let's make sure that that's true. Let's test it first. So let's exit out of this debugger and go back to this set of terminals. We can go ahead and call Pi server here. We'll go over here and do Pi client. Okay. Oh, we didn't cd change directory. There we go. Now let's Pi client. Okay. Need to cd over and then Pi client. Okay, there we go. So we have what is your name? What is your name? Let's try this. Joshua. Okay, so it's saying hit enter to continue. Hit enter to continue. Why is it showing? I don't know if that was 10 seconds. That was a fast 10 seconds, dude. Oh. I'm confused here. Why is it showing hit enter to continue twice? Okay, so you know what I did is I modified this to be, we added this progression text thing in because I couldn't find where it set the progression text. And maybe I just overlooked that. Maybe it is implemented already and we somehow like doubled it up. So let's go ahead and close this and try again. Because I'm not gonna move on any further until I get this right. And look at that. Looks like we got some recursive shit going on here. You see all that? That's recursive. Yeah. Okay. Got a wave pattern here. Okay. Alright. So let's run this again. Run it again. Alright. So we got both of them up. We're going to go to client 1. Okay, here we go. Yeah, so it looks like I somehow... Oh, I know. Okay. It does change the... It's not the progression text. It's like a different text object. That's what I forgot. I thought you had to change the progression text, but it's not the progression text object. It's a different. This right here is the progression text object. As the game progresses, where it says what is your name, that's the progression text. But this right here is like an input text box. The same thing for the enter continue text is a separate text box, because you have to read the progression text and then the hit enter to continue text box will appear below the progression text box. So that was where I was messing up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there. So now it's working. We fixed that part of the game. It looks like everything, well, actually, I don't think it's completely working, remember, because we talked about the issue with the delay and the fact that it checks the right here in the draw one. It says may have to get rid of this. We fixed that. If testing this, a regression text flashes. Yeah, we fixed that. Okay. Now we have this, which is may have to check input text final first. Issue here is that text input active is transferred before input text final. Taking a little bit of my caffeine pill here to wake back up. Okay, so it says may have to check input text final first. Issue here is that text input active is transferred before input text final is, so enters this section errantly. And I do believe that is gonna be an issue here. Because let me see if I can replicate it. So we're gonna run the server, run the client, other client. Make sure we're on client 1. See that? So I noticed that weird behavior. It's not like, honestly, I'm not so concerned about that. Wherein the it's easier to like see it than it is to just like say it. So when he goes to type his name and hits enter, now that works great. But then when you go over here and he types his name, it doesn't change his progression text from what is your name. Okay, so I can get rid of all these logs. Yeah, honestly, I'm not so worried about that. I can live with that. We could always change that later to optimize that. I'm not worried about it. Really, I'm just worried about that it works, and it seems like it works. But we do need to modify this section like we said, because text input active is transferred before text input text final. Oh, you know what would solve that? Is having a lock. Yeah, so having a lock on the if we put a lock so that we couldn't check a value unless that value wasn't being handled. But no, that's not correct actually, because like that wouldn't actually fix the issue. The issue is receiving that piece of data to checking it before it's applied, receiving it, checking it, and then applying it, instead of receiving it, applying it, and then checking it. And even if we used a lock right here before this line and said with lock do this, that would mean that it would still apply only text input active first, even if we used a lock, because there's no guarantee that input text final is gonna get sent in the same packet. So like that, locking that section wouldn't guarantee that this issue wouldn't still occur. It still could occur and would in certain instances. So I think the only real solution here is to add in a delay. So basically, yeah, we have data coming in, and we don't really need to use paint for this. It's not that complicated, but you have, let's just say this is client side, this is the server side. You have, let's say this data right here, you have two changes. You have 1 and 2. So we made 2 changes, and now we're gonna send that over. Now this arrives, and let's just say this is the preliminary stage. It's got 1 and 2 there. Now it's gonna go ahead and start applying the data. So it's got to apply those one at a time. But since there's another thread, so it applies 1 and then 2. But before it gets to 2, there's 3 threads. So there's one thread, there's another thread, and there's another thread. So this is the main thread. This is client 1 thread, and this is client 2 thread. So you got C1, C2, and MT for main thread. Let's just say in this instance this is coming from client 2. So this whole screen is C2. Now it's gonna apply 1, but as soon as this happens, let's just say it stops right here, and then it checks 1 and 2. We just put check 1 and 2. So what's happening here is 1 is there. 1 has been changed, but 2 hasn't. So it gets a bad read, and that's bad code. So what we have to do here is we have to basically add in a delay so that there's enough time for 2 to get added in before it checks 1 and 2. So now this line, we'll just say, is gone, and you can do it like this, get rid of it. So now this, we can make it so that 1 and 2 get applied. So now we have 1 and 2 that are applied, and this is registered on the main thread and everywhere else, obviously, because, you know, this is all one unit. This is the server side, so we put SS for server side, and so we need to add a delay. So instead of checking at this point, let's just say this is we need 1 second, 2 seconds, and then now it'll re-loop, and then it'll be on the 3rd second. On the 3rd second, it can now check on the main thread. So now whenever it checks 1 and 2 right here at this point in time, They both have been changed, and that is good code. That means we had enough time after reception to actually apply the data. So that's, I think, will solve this issue. And we might actually have that implemented, but I don't think we do. So let me go to server and let me see if I can find where it was, but I'm pretty sure we removed it because we thought we wouldn't need it anymore. So this would be in the receive section. Okay, so now we have the application section. So this is where that magic should happen. Okay, actually I do have this implemented. Look right here. So we have if time ns, and we have the same issue. Okay, cool. So this is great news. This is great news. So I did the same thing. Which means I need to, and I should have thought of this when I realized that I had done it in one place, that I probably have done it in another place. Is the fact that we're comparing, we'll call this issue time ns comparison bug, and realize that I was comparing against nanoseconds as if they were seconds, causing bad code. Review all instances of time ns to ensure we're not doing this, to ensure we are comparing against large, and we'll say times 1 billion integers for them to be seconds instead of nanoseconds. To ensure we are comparing against large x1 billion integers for them to be seconds instead of nanoseconds. True. Alright. So we tested and verified that our fix works 100%, and we did indeed test it. We tested it in a test file, and we tested it live, and it does indeed work. So that's cool. Now we see right here we have time ns minus earliest received time, and that should also be ns. So what we'll do actually is we'll look for time.time, and that will include time ns, since it's just ns is an extension of time. So this will allow us to see if we're using time instead of time ns. So like, you know, we're comparing apples and oranges, and it will also let us see all the instances of time ns to make sure that we're using a times 1 billion integer to make sure we're comparing in terms of seconds and not in terms of nanoseconds, because we want to make sure we're doing that, because obviously we want to compare seconds, not nanoseconds. Alright. So this needs to be changed times a billion to be 3 seconds. 3 billion nanoseconds would be 3 seconds. So this needs to be comma 1 2 3 comma 1 2 3 comma 1 2 3. So that's hundreds, thousands, millions, and then billions. So there. Now we can remove these commas, and I'll put verified correct amount of zeros, 3 billion nanoseconds equals 3 seconds. There we go. So compares the current time against earliest received time, and that is a variable, so we always use open quotations to compare variables. I mean, to denote that we're talking about variables in our comments. It's just a convention that I use. So this should fix that instance, but now we have to check other instances throughout the entire project. So we're going to search for time.time, and let's see what we're working with here. So everything should be time ns. And you know what? We might need to search for time, actually. So we're gonna do time.time and then search for just time, because like, what if we're assigning it in a one section and then like we're comparing it in another section, and whenever we search for time.time, that section isn't going to show up. But since whenever we reference any time variable or value, we always use the namespace, it always includes the word time. That means if we search for just time throughout the entire project, we will indeed find what we're looking for. So let's go one by one here first, and then we'll figure that out. So as you can see right here, this is like what I'm talking about. So we have current time equals time ns, but then we have this comparison right here of current time minus dictionary at key at 2. See, that's an indirect reference. That's implicit, not explicit. So we won't know that this is talking about that, although I did put in the comment, and that's why it's always good to do stuff like that when you're being implicit, to make it explicit in the comment or something. So it's comparing the current time with the received time, and we're using 280, and this is supposed to be 280 seconds, but we have to convert this. This is actually 280 nanoseconds, as long as the received time is indeed also time ns, which I'm pretty sure it is, because we converted everything to ns from non-ns. So this is hundreds, thousands, millions, billions. So now it's 280 billion nanoseconds, also known as 280 seconds. And we can put that we verified correct amount of zeros, 280, 1 2 3 1 2 3 1 2 3 billion nanoseconds equals 280 seconds. All right, so let's move on, and this is current client received time for 3-second comparison. Let's add it to receive. All right, if time.time ns minus earliest received time greater than or equal to 3. So here again, we're doing the same thing. This is, and where do we assign earliest received time? Let's look for that. Oh, it's right there. I'm blind. Didn't see it. Well, because we don't use the keyword, this is referencing the received cal tuplus, and this is received time. So we're gonna go ahead and assume that we are correct in the assessment that this is an NS to NS comparison. So now we have hundreds, thousands, millions, billions, so 3 billion is 3 seconds. So we can now put verified correct amount of zeros, and we'll just put 3 billion nanoseconds equals 3 seconds. Okay. I don't want to go too fast here. Let's just look over real quick. Time ns minus earliest received time greater than or equal to 3 billion nanoseconds, which would be 3 seconds. And that is indeed, yeah. If it's 1 billionth, then a billion of them is the entire value, which is a second. So that's correct. Okay, so same thing done here. Current timestamp minus current tube's receive time. So we know that receive time is ns, so we're going to go ahead and do the same thing here. And we have hundreds, thousands, millions, billions. Time ns minus tube at index 2 greater than or equal to 3 billion 3 seconds, and we can just copy this because it's the exact same thing and paste that right here. Now we can continue. Alright, time ns, okay, time ns, alright. If time ns, this is the one that we fixed already. And why do these look different? They're not different, they just look different. There we go. So they're not different. Let's continue. Alright, so we assigned round and winner sound bool to time ns. Current time equals time ns. Alright. Event handler start time. Okay. Ah, see, there we go. See, I gotta slow down because I just missed one right here. Dumbass. Let's try this again. And I know one that we need to make sure is checked because it might be an implicit reference through that function dircheck, and that is for time to timestamp comparison. But don't forget about checking time to timestamp comparison in dircheck. And we put question marks when we're not completely sure about where it is, but I think it's there. So time round end winner sound bool time ns. Alright, and this is not going to be checked or compared right there. That's for dircheck. Same thing for this. This is just an assignment. Now this one is an assignment because it's for start time, but then there's end time, and now there's the check. So this one needs to be changed because this is NS versus NS, so it needs to be in terms of billion. So we'll say hundreds, thousands, million, billion. And we verified a correct amount of zeros. We'll put 2 billion nanoseconds equals 2 seconds. Cool. Yeah, and I like this. I'm gonna save this to my coding playlist because, or Disney Princess. Yeah, I actually like that. That was good. Alright. Right, so this is fixed. Alright, so this is prior time. And it looks like we're not actually using that, so we're probably not going to find that comparison. Okay, it's probably commented out here. So it's not equal to 0.0. So this is going to be bugged because, and I'll put a little comment here. Changed this code to use nanoseconds instead of load time. Therefore, need to compare terms of billions of nanoseconds. It's not in terms of seconds. So hopefully I know what I'm talking about there. So this concerning above caution comment, this line, for example, would be bugged. Yeah, that is the same section. It's the mirror section rather. So current time equals time in S, blah blah blah, blah blah blah, blah blah blah. Alright, so yeah, so this needs to be changed to billions. Let's see, 1, 2, 3, 1, 2, 3. So we have hundreds, thousands, millions, billions. Alright, cool. I can put verified correct amount of zeros. 280. Hundreds, thousands, millions, billions, million nanoseconds equals 280 seconds. So this is assignment of the receive time. We're not going to get a comparison right here. The comparison is later, and that's right there. We fixed that one already. Alright, but here we have to check it again. So time and estimate is compared to 2, -2 greater than or equal to 3. So this is the same thing. So we need to convert this to billions. 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's hundreds, thousands, millions, billions, and then we can get rid of. Oops, totally just fucked that up, didn't I? Get rid of that. Get rid of that. And now we'll say verified correct amount of zeros. We'll say 3 billion nanoseconds equals 3 seconds. Cool. Wonderful. Isn't everything wonderful now? Alright, so these are all just text files and stuff. So we don't have to worry about those. Okay. Now we need to go through and we'll check for all the instances of just time, and this is going to be a little bit more results, 144, but it's going to help me to weed out any potential instances of this that I missed. Oh, there goes my back hurting me. Damn. So it's gonna have been an hour now. Yeah, we're at an hour and 5. And I forgot to take my little necklace out. Love my little necklace here. Alright, so I'm gonna go ahead and take a break, take a little walk, and yeah, so I'll be back in a few. We'll do one more hour, roughly, and then I'll probably call it a day. Okay, I'm back. Alright, let's smash this last hour and call it quits for the day. Alright, so we're going through time. We're just gonna look at time. Oh man, that's so many results. That's fine. It is what it is. It's got to be checked. It's not that bad. Found one. Look at that. And that one was like, that one wasn't even hidden. That was one we should have caught. See, that's why it's always good to double check behind yourself. At least behind myself, because I'm an idiot. And I'll pass this shit right up. So this is gonna be hundreds, thousands, millions, billions. So get rid of these now. We can put verified correct amount of zeros. 280 billion nanoseconds equals 280 seconds. Alright, so let's keep it going here. Okay. It's that old file. We don't have to go through that one. Damn. Alright, that's enough now. Move on. I should have put those in a different folder. I shouldn't have put those in the same folder as everything else. Because I've like modified them when fixing stuff like this. And I mean, the whole purpose of them was to be a snapshot of a previous state of the game. And by alright, by me modifying them, I totally like changed, you know, that fact. So that was actually stupid of me to do. There we go. There's one. So we have hundreds, thousands, millions, billions. Hundreds, thousands, millions, billions. Verify correct amount of zeros. 280 billion nanoseconds equals 280 seconds. Alright, yeah, so we're done. We I didn't find any. So yeah, we're good. Alright, so the last thing I want to do is look for time dot and make sure that I'm always using time time in S and not time dot time. It's old files, don't have to look at them. Yep. Alright, so we're done. Alright, we finished that task. So that should improve our data transfer system significantly there. So you can exit out of these files here. And let's go ahead and test the script and see how it acts now. So let's close all these. Except for these three. Why devlog got closed. When we were assuming time ns should be compared to a simple small int like 10 to compare against 10 seconds, but in fact we were comparing in terms of nanoseconds. Where we were assuming we were comparing in terms of seconds, but in fact we were comparing in terms of nanoseconds. So all of those code sections were bugs. Went through the entire project and found all instances of these and multiplied the compared value by 1 billion to convert to seconds. And we took our break from 4:20 to 4:30. Alright, so now let's go ahead and test the script, see what happens. See if it works, boys. Alright, so let's run this script. Server, client. Okay, now let's run the other client. And let's see, so we should get a delay. Okay, so we did get our delay. See that 3-second delay? That was what we were talking about. So we enter our name, 1, 2, 3-second delay. There we go. Okay. Now let's go over here. Put M. He's gonna get a delay. Okay. Okay. All right. let's change this to a 1 second delay. So let me find in the project where we have 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's change this to 1 second. Or we'll change it to 2. So let's change this to 2. So maybe 2 billion equals seconds. Change this to 2. This is maybe 2 seconds. So I feel like 3 seconds is plenty long, and I think 2 seconds will shorten it up and make it a little faster. Honestly, I don't know the time, the exact time of like, I don't know if we could go down to like a half of a second. You know what I mean? I don't know exactly how much of a delay there is. I know if we're doing live log printouts, it's gonna be longer because those clog up the system. But other than that, I think we could honestly, I don't know exactly how to test that. Like, that is something that I would say we could probably go down to a 1 second. But I wouldn't want to go any lower than that, just in case, you know. So I think we'll stick with 1 second. Or 2 seconds rather, just to be safe, and then, you know, we can always change it to 1 second once we get everything debugged, and then we can, you know, get a better idea of like isolate that variable to see if, okay, so we just changed this, is this gonna fix our problem, instead of like all these different variables. So now it's 2 seconds instead. Okay. Alright, so now it looks like right now we fixed that section. Everything's good. It looks like we can move forward to the next. So we're gonna jump ahead. So we finished the draw 1, which is not very far in, I'll be honest, but you know, to give myself a break, of course the beginning was gonna be more rocky than like the rest of it, so I would assume we made it through the first we made it through the first 90 lines, 89 lines, and we have like what, 1400, so we're almost 1/14 of the way there. So, but to be fair, that first day is definitely going to take a little longer than the others, because, well, the beginning section rather is going to take longer than the rest, because the other problems that we have in the project are not in this file, so obviously you have to fix them before you can even get the engine running at all. So now we got our engine running, we just have to figure out the next bug and address it. And it looks like the next bug is going to be a display issue. As you could see, it wasn't properly displaying. And verify the delays. the data application delays which utilize these nanosecond comparisons are working as intended 100%. Okay, so the next thing is gonna be figuring out the next bug, and it looks like, yeah, like that visual bug we saw here, whenever we run the script, get the other script running, it's gonna take a couple seconds. We're gonna type in his name, he's gonna be Joshua, the other guy is just gonna be M, and now he's ready to play. He's why is it still asking me for my name? Okay, it did work, it just took a second because of that delay, and like I said, we can always shorten that delay. So it looks like for client 2 it's not displaying correctly, but as you can see, I can click the card from here, but it's not displaying them correctly. And then there's another display bug, but we're going one at a time here. So, and the card flew off the screen, which isn't good. So we got a couple bugs going on here, but the first one that we're going to deal with is the fact that this layout is not in the draw animation for client 2. And let's just verify that it is indeed client 2. So let's run this again, and let's run this again, and now I'm gonna put this one offset down here so I know that's client 1, and then client 2 is gonna not be offset. So we're gonna go to client 1, we're gonna enter the name to be Joshua, his name's gonna be M, his should be ready. It takes a while to change. I might want to shorten that delay a little bit. I don't want to like shorten it too much though. Okay, so yeah, we do have verified it's client 2 that has the visual bug. Client 1 seems to work. It's client 2 here that has the visual bug. Yeah. So it's client 2. It's not laying the cards out in the draw animation positions, so we have to fix that. Okay, so let's try to figure this out. Why is it not laying the cards out in the draw animation position? Okay, this again, solving the draw animation client 2 bug. Add this to things to do at the top. So this is fixed. Time and S comparison bug. Realize there's comparing against in seconds of 30 seconds. Front to back code. Review all instances of time and S. Don't forget about checking time 2 times endure check. And I don't remember seeing that one actually, so let's find that one real quick. I'm glad I put that as a comment. So let's go to client, which is where we define dir check. Let's go define dir check. Now let's look for receive timestamp float. That's the value we're going to be looking for. Alright, here we go. So all we're doing is comparing against to see if one's greater or lesser. So we're not doing any sort of conversion. We're just comparing them directly against each other. We're not comparing them against actual integers or whatever. So that is any integers that are like explicitly written out, that is. So that's good. That means that's taken care of. We don't have to do anything there. So we can get rid of this. Don't forget about checking time. Yep, so this is done. Consider locks as issues. We'll leave that. Consider using time sleep. Consider, yeah, I gotcha. Enter continue text function skip bug. SS is setting under, yeah, we got that fixed. Too fast logic check. Data is being up to and up to. Yeah, that's actually already implemented. Cool, we didn't have to do that. Waiting other player bug. This bug has been around forever, and then I'm gonna put as of 9/4/24 after fixing a couple other bugs. I have yet to witness this bug again, which is cool. Hopefully it's gone, but it might not be, so we'll leave it around. Name type display bug. When typing in a name for P1 when backspacing after, blue box rect remains when it shouldn't. And that one actually is working. So as you can see, when you fix one bug, it fixes a few bugs. Like in that case, fixing one seemed to fix two or three. Game test debug receive order integrity perfect debug this debugging testing, and this is actually like what we're doing. So like this whole game test debug receive order integrity perfect data application, that is the natural like that is a large endeavor that is going to happen as we debug this entire project, because it is pretty much the core component of the entire project. So we're going to add this new bug, which we're going to call the draw animation client 2 bug, and 9424. Notice that for client 2 during the draw animation, the cards are not visually displayed in their staggered position. Okay, so this is probably gonna be a data transfer issue. So let's think about the order of events here. So what happens is, let's go find the actual code and let's look for the draw animation. Alright, right here. So we call locate the draw animation, which let's go see what it does exactly. We got our alarm telling me to stop, but I'm going to go a little bit further because we didn't quite hit 2 hours. We have another 25 minutes, so I can go 25 more minutes to get my 2 hour mark. I'll be happy with 2 hours. Alright, so this is doing the reverse of what the draw animation does. Current card in master deck, current card X, current card Y. So this puts them back where they go. That's not going to be our problem. Our issue is going to be, so this is the main thread. The main thread is calling the draw animation function. Let's do Control Shift F to search the entire project for it. And actually, we're just going to find def, the draw animation, to see where it's defined at. This is where it's defined at. Now, let's look and see what's going on here. So this gets executed from the main thread, and I don't like that. That's better. So then we get next card loc, and this is assigning all of the XY values. And this should get transmitted to both the it should get transmitted to both client 1 and client 2. So I think what we're having here is a data transfer issue. So let's, because this happens on the main thread, this data change is going to trigger the X setter. So what we're going to search for is def X, and that's going to show us where we are modifying this, or transferring the data rather. So if self change order check is equal to false and card data transfer is equal to true, which it would be, we then do data transfer function, we pass in 1, and game object equals none, game card group data, okay. So this is game object equal none. Let me look at that. So we're gonna open up change attribute list, go to data transfer function, and I know there's something up with whenever we have the game equal to none, it means it's a time tube adder. So if it's not equal to none, that means it's a time tube adder. So in this case, yeah, it's not equal to none. Why did it close out the file that I had open, man? Stupid ass thing. There we go. Alright. So there we have it. Alright. Now, grab something real quick. So card calls data transfer function. Data transfer function is in this file. It then passes the, let's put this in order here. So we have the draw animation call, then we have the draw animation where it's defined, then we have the X, which calls the setter, which calls data transfer function, which is in this file. So we go into this file, into data transfer function, and the parameters that we pass to it is 1 for the cal int object. So let's go over here. Cal int object, we have if cal int object is equal to 1, cal object is C1, change attribute list. Okay, so if cal object int is equal to 1, we set cal object change attribute list. Okay. SS or CS is equal to SS. Count object is equal to 1. Lock equals C1 cal lock. Okay. If adder name string is not in transferred game adders, SS or CS is equal to SS. If cal object integer is equal to 1. Lock equals C1 cal lock if adder name string is not in transferred game adders. So transferred game adders, increments of both countersense will be sent to both clients. So let's see, transferred game adders. If it's not, if adder name string is not in transferred game adders, so this adder name string would be X, right? Or this is rather card group data is the adder name string, right? Let's see. Adder name string equals caltube at 1, so that's caltube is the final thing passed, and it's at index 1, so the caltube is 0, 1. So in this case, it's self dot underscore y. Oh, I see. It's because I see the exact bug. It's because we're setting it via self dot underscore y, which avoids calling the setter on the data transfer side, which means we're trying to set the XY directly, and the means by which the rect center, which is actually the visual representation of the card on the screen, has to be, that's what this is. So if we're not calling the setter, which doesn't get called when you call it via the internal use form, which is underscore y instead of just y, that is going to not execute this line, which updates the rect center. So I believe if we change this to, let's just see where we're doing this in this file. So why did we do it like this? Appends a specific data change info to the C1 change attribute list, since this is a shared object. Shared object surrounded by C1 for data transfer preparation. But why why do we use underscore y and not just straight up y? Oh, and this was wrong anyway. Hold up. Wait a second. Oh, this is bugged. Hold up. This is bugged in a different way. This is supposed to set the... Oh, I made a boo-boo here. Okay. Okay, this is all wrong. This is, looks like I'm not sure where exactly I messed up, because card group data is actually the adder name, technically. But we put that the adder name string is equal to cal2 at 1. Okay, let me think about this. So I'm not sure. Let me look up all the instances of data transfer function and see how we call this. So is the adder name string caltube at index 1, or is it the entire what obviously should be caltube? It's not going to be the cal object int, it's not going to be the game object, so it should be caltube. Oh, I think I see what's going on here. I just call this function incorrectly. I'm calling it, well, actually, hold up. No. I'm tripping here. I'm getting tired, I suppose, because this actually is caltube at index 1. So let's see, caltube at index 1, the 1, 2, 3. We have 1, 2, 3. So this is the cal tube, and then at index 0 is game, and index 1 is card group data. So cal add name string is equal to cal tube at index 1, which is card group data. So card group data is not in the transferred game adders. Okay. So if it's not in the transferred game adders, so we have SS, okay, it would enter this. If cal object is 1, cal unlock. Pattern name string is not in, yeah, so it would enter this. It would increment both these because it's incrementing both counters since it will be sent to both clients. That part's correct. Okay, then we have this next section which says cal tube equals current time, cal tube 0, cal tube 1 to 2. So cal tube 0 is going to be val because cal tube's the last thing, so it's going to be vals and then self dot underscore y. And this is supposed to be the dir string, adder name, and then data. Let's see. Dir string, yeah, okay. Cal tube 0. See, I'm tired. I'm looking at this wrong. Yeah, so we have cal tube 0, which is the dir string. That's correct. Then we have at index 1, which is the adder name. Okay, that's right here. Now we're at cal tube 2, which is the actual data. Okay, which is right here. And this data is a tuple. Alright, there we go. Okay, now then we, if SSJS is equal to SS, which it would be, cal lock list function, we pass in the cal object, append, we pass in the cal tube, and then lock. Okay, so cal object a cal tube lock, so cal object a cal tube lock, cal object, the wrong one, cal object a cal tube, and then lock, cal object a cal tube as the data, and then the lock. A list is equal to the cal object. We assign the cal object up above, which is the C1 change attribute list. So we're with the lock, if a method is equal to A, which it will be, we append to the cal object, which is the C1 change attribute list, the data. Okay, and that's what we want. We want to append the entire data to it, and the data here is going to be the entire cal tube. Okay, and we need to transfer all that to have the adder name and the dir string and all that, so that should be right. Okay, then game object is not equal to none, but it is equal to none in this case, right? Let's see. Yeah, it is equal to none in this case. So in this case, we would not actually run that section. So this actually all looks good. There's nothing wrong with any of this code that I'm seeing. I thought I saw a bug, but I was confused. I was tripping. The bug that I thought I saw it was not a bug. Let me just triple check just to make sure. So we're just passing in the self y. So how do we know that like it's supposed to be for x? Like how do we know that based on what we're sending? Well, okay, because that's the format for card group data. Okay. So then the next step would be the data transfer, which means whenever now that we have populated the C1 change attribute list, we now would go to server and we need to find the 20, let's see. Oh, we're actually 4 more minutes. Alright, yeah, 4 more minutes, so we're almost done here. Let's see. Where is this section that I'm looking for? It's going to be the send section, right? Yeah, it's going to be the send section. Oh, so this might have something to do with the transfer, client receive data transfer. No, that's not going to be it. Not that section, not that section. Start receive section. Start application section. Okay, here we go. Start send section. Alright. So if current client ID is equal to 1, it acquires this C1 cal lock. It checks to see the length of the attribute list. It releases the lock. It sets these values of cal lock, con lock, other con lock, with cal lock, associated change attribute list equals C1 change attribute list. Okay. If current client ID is equal to 2, which it's not going to be. And if preliminary section ran is equal to true for 2, and we run dir check, we remove certain tupes from that change attribute list. We have the calloc list function, which removes all of those values that we don't need to send from dir checks filtering. Then if it's still populated, we pre-serialize our data, go ahead and pickle it, create our header, then we send it, okay, and then so that sends it to the associated client. Now for 1 is equal to game. Oh, that's why. Right here. This is the bug. Because tup1 is going to be well, hold on. Shit, I lost my spot. Okay, here we go. Where is it? If tup at index 1 is equal to game, Okay, because when it appends it to the changed attribute list from here, it actually makes it so that the dir string is set to index 1. So the index 1 is going to be the dir string, which would indeed be game, which is the case for this one, because it would be index 0 here, and then it gets changed to index 1. It is indeed game, and that's that's gonna trigger it getting removed. So this is the bug. Alright, cool. So we found our bug, and I'll put below line 99% certain this is cause of C2 draw animation visual bug. It is being removed because dir str is equal to game. Need to change this line to weed out only those game adders which do not need to be transferred to C other client. Okay, so this is gonna be an easy fix. So this is cool. This is always nice when it happens like that. We followed the logic from start to finish and we found our issue. But be careful, check to ensure not affecting other code references, because this code applies to a lot of different things. Alright, so we're done for the day. We're gonna go ahead and go to devlog. We're gonna put our time ending at 5:25. We began solving the draw animation client 2 bug. Almost certainly located the root cause of the bug. See line number 835 in CirPy. Okay, and now we can go ahead and stage, commit, and push our changes. So we'll put the time as 5:26 to 5:29, and let's go over to things to do, and I'll put 99% sure found location of bug. See line number 835 in CirPy. Cool. Alright, so we put our time up here as stopping at 5:29. So 3:03 to 5:29 is indeed 2 hours and 26. So we'll just go ahead and say 2.5 hours. That's close enough. We'll get rid of this little break time log. And we forgot to put our pound sign, which is convention, at least for how I do my devlog. We have to cd out to the correct root directory of the project, and now we have. So we're gonna do git branch to check and make sure we're on the secondary branch, which we are. Now we can do git add dot to add everything, and we can ignore these LF warnings. We can do git commit -m, double quotes to paste in our devlog, double quotes to close it. We successfully committed, and we have 13 files changed, 47 insertions, and 65 deletions. Now we're going to do git push Canasta secondary, and go ahead and push that. Now we push those changes, everything worked. So what we're going to do is we're going to close this out. we're gonna go to programming, projects, Canasta. We're gonna copy this entire directory. We're gonna go into the backup. We're gonna delete the old one, hit OK when this Google Drive warning message pops up. Paste in the new project, enter into it, go into the text folder, into devlog file, control end to look at the last entry. It is the same date as today's date, which means this is the actual proper backup. And now we change the title of the backup folder to reflect today's date, which is the last time it was backed up. And now we're done for the day, guys. I'll see you next time, and have a